All right, so we're going to talk about weighted voting today. So the Electoral College is used to determine the winner of our presidential elections. So there's a little quote from Wikipedia here. Critics argue that the Electoral College is archaic, inherently undemocratic, and gives certain swing states disproportionate influence in selecting the president and vice president. Proponents argue that the Electoral College is an important distinguishing feature of federalism in the United States and that it protects the rights of smaller states. So to summarize, the Electoral College is an example of a weighted voting system. So different states in the country have a different number of electoral votes. And the way we determine how many votes each state gets is based on that state's population, right? So the states with the largest populations have the most electoral votes. That's why like in an election year, when they're doing election coverage, you see this map of the United States and the states going red or blue, right? Because yeah, like the states that have the larger populations are more important to get than others. And to be elected president, you need a certain number of electoral votes. So you go after the states that have the most electoral votes. So it's not one person, one vote, right? That's it is a distinguishing feature of our election system. So California has 55 electoral votes, for example, and Montana has 3, right? So California has a larger say in who becomes president than Montana. And the reason behind that is that there are more people in California than there are in Montana. So today we're going to introduce weighted voting systems, and we're going to look at how to measure power in these systems. So California seems like it's a lot more powerful than Montana in making this decision of who's going to be the president, but how much more powerful and how do we measure that? So another example of a weighted voting system is 3 stockholders who own 10 shares, 9 shares, and 3 shares of a stock. Okay, so the stockholders vote yes or no on motions, each share counting as a vote. So suppose that a motion needs at least 12 votes to pass. 12 is called the quota. So this means that 12 votes are enough to defeat a motion. So we denote a weighted voting system with this notation. So we use square brackets. First you write down the quota, that's the number of votes you need to pass a motion. Then you write down the weights of the different players in decreasing order. So if I was going to do this for my stockholder example, first you write down the quota, which is 12. You need 12 votes to pass a motion. Then you put a colon. And then we write the number of votes each player has, or each stockholder has, in descending order. So I would write 10, 9, and 3. So those are the number of votes the 3 players have. Does that make sense? Okay. So let's say we have 4 friends who decide to start a company. And it's going to take $200,000 of capital to get this business off the ground. Player 1 puts in $80,000, and player 2 puts in $70,000, and player 3 contributes $30,000, and player 4 contributes $20,000. So the friends decide that those people who put up more money as an investment should have more of a say in business decisions. So they decide that every $10,000 contributed is going to be equal to 1 vote in all business decisions, and the quota will be set at 2/3 of the total votes. All right, so how many votes are there in this partnership? 20, because there were $200,000 invested. Every $10,000 is a vote, so there are 20 votes total. Okay. So the quota is going to be 2/3 of the total. What's 2/3 of 20? We might need a calculator. So 2/3 of 20 is 13 1/3, but you can't have 1/3 of a vote, right? So if 13 would be too few, right? Because that would be fewer, that would be less than 2/3. So we're going to need 14 votes to pass a motion. 2/3 of 20 is 13 1/3. You can't have a piece of a vote. So you have to round it up to 14. Because rounding down would be fewer than 2/3. Wouldn't be enough. All right, so let's write this partnership. We're going to describe it mathematically using our new notation. So square bracket, you put the quota first, which would be 14. And then you put the weight of each player or each shareholder or business partner. I use the term player sort of as the generic term for the people who are voting. So I put the number of votes each player has in descending order. So player 1 who put in $80,000, how many votes do they get? 8. Good. And then player 2 is going to get 7 votes, and player 3 will get 3, and player 4 gets 2 votes. Okay, so there's some vocabulary you should know. So when you're doing your reading on this section, you should pay attention to vocabulary words dictator, veto power, and dummy. We'll use those words in these examples and you'll get an idea of what they mean. Okay, so what happens in this example, right? 14, 8, 7, 3, 2. What happens if I were to lower the quota to 10 votes? Pragmatically. Okay, so I'd have to lower the votes that each person would get. Why?
It would be 2/3 of, because 14 is 2/3 of.
Right, yeah. So I'm changing my quota rule. Instead of saying it's 2/3, now I'm saying it's 10. Is there any reason I shouldn't do that or couldn't do that? You could have ties. Yeah. The 7 and the 3 and the 8 and the 2 could vote in 2 sets of alliances, and then you'd have ties. And ties are not good. I mean, that defeats the point of the voting, right? So if I 10 votes, I could have ties. Not good. What if I raise the quota to 19? What are the sort of implications of doing that? Yeah, then all of the votes might as well be equal, right? This forces a unanimous decision. There's only 20 votes in the system, so it might as well be 20, right? In which case, all 4 players are actually equal, even though they have different weights. So in this case, we would say all 4 players have equal power. Which seems weird because we assigned them different votes, different numbers of votes. So there's only 20 votes total in the system, right? 8, 7, 3, and 2. If I make my quota 19, the only way to get to 19 is if all 4 people vote together, if they make a unanimous decision, which means I might as well have made the quota 20, right? And any one person could stop something from happening, right? Even though this player 4 only has 2 votes, they've got the same amount of power as the player with 8 votes to stop a motion. Yes.
Why would you change your quota anyway? What would be the need?
you probably wouldn't. I'm just trying to show you what would, yeah, I'm just trying to talk about, yeah, yes, why we set the quota the way we set the quota in the first place, and to demonstrate that we need a better way of measuring power than just counting votes, right? Because this looks like everyone has very different power, but if you set the quota at 19, now they're all equally powerful. So I'm just sort of trying to show you the need for a way to measure power. Yes. Yeah. Okay, what if I raise the quota to 21? What are the sort of, yeah, I'll never reach the quota, right? Because there's only 20 votes in the system, so we can't ever make a decision. So sort of my conclusion between these two guys is that your quota has to be more than half. Otherwise, you could have ties. Right? But it can't be more than the total number of votes. All right, here's. Well, it can be. It can be. You just have to know the implications of what you're, of the equal power. Yeah. All right, so here's a totally new system. The quota is 11. The players have 12 votes, 5 votes, and 4 votes, respectively. What can you say about this particular partnership? They do?
Well, no, the guy that has 12, it's the one, yeah, the guy that has 12.
The guy who has 12 votes can do whatever he wants, or she wants, right? So the quota is 11. This player, all by themselves, meets the quota. We call that player a dictator. It doesn't matter at all what player 2 or player 3 thinks, right? Whatever player 1 wants happens. They can reach the quota all by themselves. All right, suppose there's a king who can be overruled if all 4 of his advisors disagree with his ruling. Okay. But only if all 4 advisors disagree. So there's 5 players total, a king and 4 advisors, right? So could you write down a voting system with a quota and the weights of the 5 players that models this situation? King who can be overruled if all 4 of his advisors disagree with him. Okay, so I saw several answers that could explain this situation, and there isn't a ton of detail in this, so there's more than one answer depending on how you interpret this. So if I'm going to use my standard notation, so I would put the quota, and then there's 5 players, the king plus his 4 advisors. 1, 2, 3, 4, 5. Okay, so let's just set a quota. 20, okay. Now, the king, we want to have a lot of power because he's the king, right? We want him to have a lot of power because the only way he doesn't get what he wants is if all of his advisors are against it. Right? Yeah, so why are we going to give him 19 though and not 20?
Because if you had 20, you have quota, you have power.
Yeah, if we gave him all 20 votes of the quota, he'd be a dictator and nobody could stop him, right? Even if all 4 of his advisors disagreed, right? So if we give him 19, we're giving him a lot of power. He's very close to the quota, but he can't reach it without somebody else, right? All right, so what should we give the 4 advisors? Yeah, 5 each, yeah. Right? Because then 5 times 4 is 20, so altogether they can reach the quota. Yeah. So there are many other possibilities, An equivalent one would be if we had the quota at 4, give the king 3 votes and each of the advisors 1. There are lots of others. The 4 advisors don't have to have equal votes, right? But you have to make it so that you can, the advisors can only reach the quota if all 4 of them vote together. If 3 of them alone can reach the quota, then we haven't satisfied the description here. Does this make sense? Okay, for now, good. Okay,
Still technically go over the quota,
can who go over the quota?
the advisors.
Oh, yeah,
So it'd be like they could get 6 or something.
yep, yep. Yeah, and any group of players that meets or exceeds the quota would be we call that a winning coalition. All right, so some vocabulary that you're going to read about in the book would be a sequential coalition and a pivotal player. We're going to do an example of a way to measure power using markers and 3 people in this room. Okay. Okay, so I have all the pivotal players identified, so hopefully yours match mine. So my next step is to determine how many times I circled each player. Okay, so player 1, player 2, player 3, player 4. Okay, so first, how many total circles are on the board? 24, because there are 24 sequential coalitions. Each one has 1 pivotal player, so that's a total of 24. So for each of these, I'm going to measure, of those 24, how many times was this player pivotal? So how many times is player 1 circled? 18. So this whole row, or column, this whole column, and this whole column, player 1's pivotal. So 18 out of 24. And then player 2, how many times player 2 gets circled? 2. Just 2 in this first column. And then player 3, 2, and player 4, 2. So when you're doing homework in my math lab, they ask you to reduce these fractions. I like them with the denominators all the same because then it's easier to compare, right? 18 out of 24 versus 2 out of 24. My math lab will ask you to reduce these, so we'll just remind you how to do that. I can divide the top and bottom of this fraction by 6. 18 divided by 6 is 3, and 24 divided by 6 is 4, so 3/4. And then player 2, that would be 1/12. Player 3, 1/12, and player 4, 1/12. So that means that player 1 has 3/4 of the power, right? And each of the other 3 players have equal power to each other, 1/12 each. And to help you, I believe my math lab wants you to put reduced fractions in, so you would put this into my math lab. But just to talk about, for practical purposes of reasoning through what this means, you might change these to percentages. So player 1 would have 75% of the power. And then 1/12 as a percentage. Nope. Yeah, I can just take 25% and divide by 3. 8 1/3%. So each of these players has 8 1/3% power. So the results are a little bit surprising because the votes were 5, 4, 2, 1, 1. So you might have expected player 1 to have the most power, right? So that isn't surprising. But the 2, 1, 1 would make it seem like those players have different weights or different amounts of power. But it turns out that they're all equal, okay? Even though one player has 2 votes and the other 2 have 1 each. So this is a measure of the percentage or the fraction of power controlled by each player. Does that answer your question about the practical uses. So in any situation where you're giving players different weights of votes, you can use this to determine actual percent of power controlled. Okay, so now I'm going to have you try this. Frontier High School has a school board made up of 3 members from Deerfield and 2 from Sunderland, 2 from Whately, and 2 from Conway. For a motion to pass, a majority of the board has to vote yes. Represent this using our notation for weighted voting and calculate the SSPI, that's the Shapley-Shubik Power Index, for each town.